So again, good afternoon. Our first lesson here is all about sinusoid. Okay. So according to our PowerPoint here, the objective of our first lesson here is to understand the basic properties of a sinusoid's graph and its application to AC circuits. Okay. So in here we have the definition of the sinusoid. According to the definition, a sinusoid is a signal that has the form of a sine or cosine function. It may be in sine or it may be in cosine. Say for example, in our illustration here, our sinusoid is in sine function. Say for instance, this curve here or this graph here, we have this sinusoid expression for our voltage, say B of t. B of t is equal to Bm sine omega t. So that means our sinusoid here is in sine function because of this sin, S-I-N, sine. You know? Otherwise, pwede natin gamitin yung sinasabing cosine, say Bm cos WT. Say Bm, B sub M, cos WT. Say B sub M cos sine omega t. Something like that. No? Also in our given expression here, we have the positive and negative half cycle of our sinusoids. The positive half cycle here correspond dito sa first half cycle, positive first half cycle, and the second, this negative second half cycle. So if we combine these two, then will give us this complete cycle that is equivalent to 360 degrees from 0 here, 0 degree up to there, or say 2 pi radian. No, for one complete cycle, we have 360 degrees there, or 2 pi radian, or meaning for a complete cycle, we have what we call time period t in second. Okay. So what do you mean by this BT here, B sub M, omega, T, and omega T? Okay. Let's first have this, this B sub T. Okay, this B sub T correspond to the instantaneous value of our sinusoid in both course. Otherwise, if it's the other one, say the current, then the sinusoid correspond there is small I t, I of t. That's the sinusoid, that's the instantaneous value of our sinusoidal current then. But since we are following these expressions, B equal to Bm sin omega t, so we can simply say that the instantaneous value of our sinusoids here, sinusoidal voltage is B sub t, or B of t, I mean. And the amplitude is B sub M, or the maximum value of our sinusoidal voltage or sinusoids. And the W here correspond to the angular frequency or radian frequency. And the unit is radian per second. And the time t here correspond to the time in second, and t here correspond to the time t in second. Then if we multiply W to t, then it gives us this what we call, it will give us this what we call argument of the sinusoid, say in radian. While in radian, because we know that the unit of our W is in radian per second, if we multiply it by time t in second, kakancel yung second natin. So the result then is radian, or say degree kaya. No? And we have an additional here, capital T. So this is the time required to complete one cycle. As I said a while ago, one complete cycle here correspond to this distance from 0 to 360 degrees in second. That's the time required to complete one cycle. And again, in one cycle, we have two half cycle. One is positive and the other one is negative. This is the location of our positive half cycle and this is the location of our negative half cycle. No? So to complete that, we have to consider the positive and the negative there. And the frequency naman is the number of cycle per second. And the unit for this frequency is in hertz or say Hz. And the reciprocal of this correspond to time t here, capital T, or f equal to 1 over t. And at the same time, the angular frequency here can also be expressed, say, into 2 pi f. W, radian per second, is also equal to 2 pi f. We know that the frequency f here equal to 1 over t. If we substitute our f here equal to 1 over t in our formula 2 pi f and solving for t, capital T, then it will give us, say, t equal to 2 pi over w. No? If we change this f to 1 over t and if we solve that t after substituting f here, then our t will be equal to 2 pi over w. So that's how we represent our time t period using this formula. Okay? So general sinusoidal expression can be represent like this. Let's say, for example, b of t equal to bm sine omega t, this time plus phi. In the previous one, our expression is b equal to bm sine omega t without this angle phi. No? Okay. If we consider this angle phi and we want to draw the graph of this b of t, so this is how we draw our graph. As you can see here, so this is our y-axis and this is our x-axis. The intersection of our x and y-axis is the 0 degree. No? 0 degree. Okay. In the previous one, our sinusoid starts from 0 degree intersection of our x and y-axis. Right? This one. So it starts from 0 degree dun sa intersection ng x and y-axis natin. So that's why our expression for the sinusoid here is Pm sine omega t plus actually 0 degree. Pero hindi na natin nilagay yung 0 degree because it is understood for us if our sinusoid starts here, then we simply mean that our sinusoid is Bm sine omega t. Or say Im sine omega t if it's current. If it is current. I sub m sine omega t. But in more general expression, we include that phase angle other than 0. Say for instance here, we use positive angle plus phi. What do you mean by that? If we grab it, this positive phi here must be located to the left side of our y-axis here or along the negative x-axis. Along the negative x-axis. So we know from 0 to the right, we have the positive degrees there, say 30 degrees, 60 degrees, 90 degrees, up to say 360 degrees. With respect to the left of our 0 degree, then we'll have say negative 30, going to negative 60, to negative 90 degrees, say up to negative 360 degrees, negative 360 degrees. If you notice here, it starts from the negative x-axis, but the angle there is positive. So that's how we represent our sinusoid here. If we start from the negative x-axis, the sign of the angle must be positive. Let's say, for instance, if we move this one, okay, sorry. Let's say, for example, if I move this one to the left side here, if we start here, then our sinusoid will be like that. So if we start here, to the right side of our intersection here, then the expression must be equal to Bm sine omega t minus phi if we start here along the x-axis. No? So that's how we express our sinusoids then. But if the sinusoid start to the left side of our, this one, x-axis, say negative 30 degrees there, then the expression will be negative 30 degrees. So if it is 45 degrees naman, then the sign is positive 30 degrees. I'm sorry, positive 30 degrees. If the sinusoid starts here, then we'll have Bm sine omega t minus 45 degrees. Okay? So that's how we interpret if the angle is positive, or say if the angle is negative. So we interpret with respect to the x-axis, our expression there. Actually, if you want, we can also interpret it with respect to the maximum. Let's say, for example, this one, this maximum here. Then from there, we can, okay. Let's say, for example, if we want to express it with respect to maximum, so we have to look for this angle here. No? Then after that, we're going to indicate that angle in our phi here. Yun, ganyan yun. No? But for the meantime, sige, wag lang muna yon para hindi lang tayo nalilito. Ito na lang ang consider muna natin yung sinasabi natin. Nag-start yung sinusoid natin with respect to the x-axis, either positive x or negative x. If it start from the negative x, then must be positive there. Start from the positive x, must be negative there. The sign of our, sandali. Okay. Next, we have, ano ba? Ano ba itong kasunod na to? Ayun, okay. So, what do you mean by this W plus P? W plus P is the argument of the sinusoid as a whole. And the previous one, our sinusoid is simply WT because we assume that our angle feeder is 0. So we simply say then that our argument in our previous graph is simply equal to omega t. But in our case here, since we add this phi here, then omega t plus phi is our also our argument as a whole, no? Okay, and the phi here corresponds to the phase angle, or simply the phase of the sinusoid in degrees or in radian, maybe in radian or maybe in degrees. Of course, if we use radian for the product of WT here, we must use degrees also for the unit of our phi here. But if we use degrees for our omega t here, we must use degrees also for our phi here. Dapat both unit here must be the same, say omega t and phi must be the same for us to get the correct value for the sine or cosine of omega t plus phi. Otherwise, the value of the sine or cosine omega t plus phi will not be correct if we use, say, omega t unit in degrees or radian, and phi in degrees. If we do that, then we'll get an incorrect answer for the sign value of this argument. No? Okay, must be both in degrees or in region. Okay. So there is an illustration here kung saan sinasabi niya dito, the negative values or the negative half cycle only indicates that the voltage generated changes in polarity or the changes in the direction in the case of current. Say for example, in our illustration here, as I mentioned a while ago, we have the positive half cycle and the negative half cycle. The positive half cycle correspond to the positive polarity of our voltage, and the negative half cycle correspond to the negative sign of our voltage. For the current, for the positive half cycle, let's say for example, the direction is clockwise, but when we consider the negative half cycle, then we can simply say that the direction of the current there is the reverse of the direction of the current in the previous one in the positive half cycle, as illustrated in our figure here. No? So we have an illustration here. In the first half cycle, positive half cycle, the sign of our voltage is located there. But if you consider the negative half cycle, as you can see here, the positive is located at the bottom part, or meaning the negative is located there. Now for the current, if the direction of the current for the positive half cycle is say from left to right, then if you consider the negative half cycle, the direction of the current then will be opposite from the first direction of our current. No? So this time, the direction is from right to left instead from left to right. Okay. Next, we have this identity. If we try to recall our trigonometry in our first year, so we have this identity, the negative sign, cosine, plus minus cosine, as well as this double formula for the sine and cosine function. Also, we have uh, this additional identity, say the combination of cosine and sine, say a cosine omega t plus b sine omega t is equal to c cosine omega t minus, not plus. If it is positive there, so the sign must be negative here. So following this, the result for the sum of this combination cosine and sine is cosine omega t minus phi. So how do we get that c here? So by Pythagorean theorem, c here is equal to the square of the sum of the square of the coefficient of cosine and sine here. Say square root of a squared and b squared. For the angle theta here, simply equal to arctangent of this sine and coefficient of sine and coefficient of cosine, say arctangent of b over a. Angle theta here is the angle measured from the positive x-axis, either clockwise CW or counterclockwise direction. So the sign of our theta is said to be positive if we use counterclockwise direction with respect to the positive x-axis. Otherwise, if we use the clockwise direction, again with respect to our positive x-axis, we said that the sign of our theta is negative. If we use the clockwise, the sign is negative. If we follow the counterclockwise, the sign of our theta is positive. So, okay. So this is how we determine the value of our C there. Okay, so this is the coefficient of our cosine is located along the positive x-axis, and the coefficient of our sine omega t there located along the positive x-axis, positive y-axis I mean, and the result will then be equal to that C. Then we can get this C by simply following our Pythagorean theorem here, say C equal to square root of a squared plus b squared. And the angle between our C, the hypotenuse, and our A here correspond to the angle theta there. Say A equal to opposite over adjacent. Arctangent B over A correspond to our theta here. Theta equal to arctangent of B over A. Opposite over adjacent. So that's how we determine our theta. And at the same time, I just mentioned here, how do you know that the correct answer for our theta is positive or negative? Or how we know that our theta is located in the first, or say it's located in the second, third, or fourth quadrant? So to be able for us to determine the correct location of our sinusoids, so we have to consider the sign of the coefficient of our sinusoid. Let's say the sign for our cosine, the sign for our sine function. No? So meaning to get the correct answer for our angle, their phase angle, we have to use graphical solution. No? We cannot rely directly on our calculator for us to determine the correct angle of our uh, sinusoids. No? If we have a combination of cosine and sine. So later, I will going to tackle that, no? After this some few exercises here. So in our exercises here, first exercises, we are asked here to find the amplitude. Amplitude is say B sub M or I sub M. B sub M for the current, I sub M for the, B sub M for the voltage, I sub M for the current. Maximum value of the voltage, maximum value of the current respectively. Phase angle, yun yung phi or theta. Period capital T, frequency, the reciprocal of this period capital T. Let's say, for example, we have 4 sine T. 4 sine 5T. So by inspection, the amplitude here is 4, which is the coefficient of our sine function. The coefficient of our sine function is 4. That 4 corresponds to the amplitude. Let's say, for instance, this sinusoids is a voltage, then our amplitude B sub M equal to 4. Let's say, for instance, if our sinusoid here is current, then this 4 correspond to our I sub M. The amplitude of our current is 4, I sub M. Since wala namang binanggit kung ano ito, pwedeng sabihin na lang natin, our amplitude is 4. Then next, what is the phase? There's no angle here. It is automatic for us that the phase angle here is 0. How about the period? Period T from the formula, period is what? 2 pi over W. Na? 2 pi over W. Let me see. Okay, so the period T by formula is 2 pi over W. So 2 pi there is constant, 2 pi over W. What is the given W here? Given W is 5. So 2 pi over 5 is our capital T, period. And after that, if you take the reciprocal of that, then it will give us the frequency here. Actually, we have a solutions here. So this is the solution for our 4 sine 5t. So it is mentioned there that it is mentioned here that the amplitude is 4. This is the coefficient of 5t. And the phase angle is 0. There's no additional angle here. There's no angle, or there's no given angle. So meaning our phi is 0. And the period T is 2 pi over W, substituting our W equal to 5 here. Then our capital T period is 1.257 seconds. If we take the reciprocal of this, then it will give us this what we call frequency. So apat yung tinatanong. We have 4 questions here for each amplitude, next followed by phase angle, then period capital T, and the last one is the frequency F. Okay. So we simply say the amplitude is 4. Kasi it doesn't mention here if this expression is it voltage or is it a current expression? It's not mentioned there. So in our solution here, we simply say that the amplitude is 4. Otherwise, if it is current, we can simply say our amplitude I sub m equal to 4. If it is voltage, we can simply say our amplitude B sub m equal to 4. Something like that. No? And for letter B, this is 4 cosine 5t plus 33 degrees. Again, the amplitude, coefficient of cosine, 4. The amplitude is 4. Phase angle is this time given 33. Phase angle phi is 33. Period T, parehas dito because our W is 5. So 2 pi over 5 is 2 pi over 5 is 1.27 second. This one. And then the reciprocal of this is 0.796 hertz cycle per second, or simply cycle, or simply ADC for the unit of our frequency F. Then for letter C, ayan, amplitude is 6, angle is 0, time is, period is 1, 2 pi over W, 2 pi over 2 pi, 1. Yan, 1 second. And the reciprocal of that, of course, 1 hertz. Okay. So there's an additional illustration here regarding how to interpret a sinusoid. Let's say, for example, if the graph starts from the zero axis, then we can say that's a sinusoidal current, sinusoidal voltage, and the function then is sine. If it starts from the maximum there, so we can say that our sinusoid is a cosine function, No? Okay. So if it starts from 0, it's sine. If it starts from the maximum, then we can interpret we can interpret as cosine function. So next, so for letter D here, in here we have a combination. We have the sum of cosine and sine. So the first expression is in cosine and the second expression is in sine. So of course we cannot combine directly of these two sinusoids for us to say that the sum of cosine and sine here equal to 4. Say coefficient of cosine here is 1, the coefficient of sine is 3, and we combine 1 to 3, the result is 4. No, the answer is not like that. The answer of these two sinusoids is not like that. So we have to follow the formula. But before that, we have a given note here, and there is a corresponding identity for us to solve this exercise here. So we have to follow this A cosine omega plus B sine omega t. A cosine omega t plus B sine omega t identity that is equal to C cosine omega t minus theta. So we have two given notes here. Number one, we can only use the above identity, this one. We can only use this above identity if the W here, the argument, the argument, or the angular frequency of the two function, or yung radian frequency, angular frequency of the two functions, say W, are the same. No? In our case here, we have the same W. What's W for cosine? 2. What's the W for our sine? 2. So meaning we have the same W here, meaning we can add these two sinusoids. Otherwise, if sine is different from cosine, say for instance, W of our sine here is say 5t, in here is 2t, 2 for cosine and 5 for sine, then we cannot add this cosine to sine function for us to determine the resultant value of these two combination, of this combination. We cannot do that, no, if they have different W. Since they have the same W, then we can follow this identity here. No, we can use this identity here. And number two, prior to the application of the identity, we have to get rid of the phase P of each function. Na? Okay? So, kukunin muna natin yung phi. No? Kukunin muna natin yung phi dito. So, how they get phi? When I say phi, this is the resultant of this combination. Say, for instance, this one. No? This one. Let us expand the given identity following. Let's expand the given using the following identity. This double angle formula for the sine. Okay, we use negative there because in our given here, we have a negative 5 over 6 here. So that's why we follow this sine A minus B, not sine A plus B, because of that given sign for our sine function here. Then next, cosine A plus B. So we use this A cosine plus B because of this given function here, at the same time because of this sign here. That's why we use cosine A plus instead of cosine A minus because of that sign there. Now, so by identity, sine A minus B is sine A cosine B minus cosine A sine B. Sin cos cos B. Diba? Cos A plus B is cos minus sine AB, respectively. Okay. Okay, knowing now this formula and the same time based dito sa mga signs na mga given sinusoids natin, okay, we can now consider the first term there, cosine 2t plus pi over 4, first sinusoid, I mean. Okay, so we have cosine 2t plus pi over 4 following this identity. So we'll have cos minus sine. Cos 2t, cos times cos pi over 4. Next, minus negative sine 2t sine pi over 4. By using our calculator, cosine phi over 4 is square root of 2 over 2. Let's say, for instance, we want to convert this pi into degrees. So we know that phi radian equivalent to 180 degrees. So if we use degree mode in our calculator, then cosine 180 over 4 is cosine 45 degrees. Cosine 45 degrees, of course, is 0.707 or say square root of 2 over 2. So similarly, the sine 4 over sine 5 over 4 is also equal to square root of 2 over 2 because we know sine 45 is also square root of 2 over 2 or say 0.707. Then after that, we can now consider the second term, say 3 sine 2t minus pi over 6. Then following this identity, so we have sine, cosine minus cosine, sine. So we have sine 2t cosine phi over 6, then minus cosine 2t sine phi over 6. So again, if we convert, say, this 2 degrees, then we'll have cosine 180 degrees over 6. 180 over 6 is 30 degrees. What is cosine 30 degrees? Cosine 30 degrees is square root of 3 over 2. Or what is sine phi over 6 or sine 180 degrees over 6 or sine 30 degrees. Sine 30 degrees is 1/2. Or if the calculator is in radian mode, then you simply follow this, say sine pi radian over 6. Sine pi radian over 6 is also equal to 1/2. No? Okay. Then knowing now the value of this cosine phi over 4, sine of cosine phi over 6, as well as this one. So we can now substitute the value of this cosine as well as 3 sine here. Okay. Okay, so this now the corresponding value of the cosine and the sine here. And after that, what we did here, patong, ayun, okay. So for the continuation of our solution, so we distribute 3 here. So this is now the result. Then after that, we combine like terms, say cosine 2t here, square root of 2 over 2, minus negative 3 over 2 cosine 2t, this one. Then next, combine the sine function here, this the combined expression of the sine. Then after that, we compute the value of this equal to negative 0.79, followed by this positive 1.89 sine omega, sine 2t, I mean. Then afterward, now notice that the result is simply like this. What I mean, we cannot yet say, oh, the angle phi is like this, equal to this, because in our expression here, after we follow the identities there, wala pa tayong nakikitang angle dito. Still, a combination of cosine and sine. So for us to determine the result, the final result for this expression, we can follow, say, the formula using quadratic or Pythagorean theorem, say c equal to square root of a squared plus b squared. No? Okay, so our a here is negative 0.79, our b is coefficient of our sine is 1.89, correspond to b. Then following this formula, then the result is 2.05. Okay, so this is now the amplitude. Okay, how about the angle? We are looking for what? Amplitude followed by phase, then period and frequency. For the amplitude or magnitude, we have the square root of a squared plus b squared, say 2.05. How about the angle? Theta. Okay, so if we follow directly the formula, theta is arctangent b over a. So for our substituting the value of b is 1.89 as well as a, then it will give us, say, negative 67.32 degrees. Okay, so this is the calculated value, but there's a given note here. So we have to make sure that the calculated angle is correct. Double check by graphical method. Meaning, maybe we are not sure if this angle is correct. No? So to check that, use this graphical representation. Okay. How do we follow the graphical representation? Okay, we know that the first term here is in cosine, and it has a negative 0.79 magnitude. So if we draw this in our Argand diagram, it must be located here, isn't it? Because it is negative and it has a function of cosine. Since it is in cosine function, it is located along the x-axis. So since it has a negative magnitude, so that means it's located in the negative x-axis. This one, negative 0.79. And the second one, the second term is 1.89 sine 2t. Where is that? So the sign is positive, meaning it is located along the positive x-axis, sine. Since it is sine, either is located along the positive y or negative y-axis. So since it's positive, it's located along the positive y-axis, this one, 1.89, 1.81, 1.89. So meaning the location of the sum of our two sinusoids must be in here, in the second quadrant, not in the fourth quadrant as before, simply following the formula, say, of theta equal to arctangent b over a. We cannot simply rely on this formula by simply substituting the given values as well as the sign of our uh, sinusoids. No? Okay, for us to correct that or to see if this angle is correct, so we have to use this graphical representation. Okay, knowing now that the location is in here, this is the value of our C. Okay, uh, then to get the correct angle there, we can use 180 degrees and this given value of our angle here, because if you follow, say, arctangent of 1.89 over 0.79, the angle there is 67.32. Then to get the correct angle or base angle, we have to consider the reference axis o yung positive x-axis. So for us to correct to get the correct phase angle, we have to start from the reference or from the positive x-axis. So since the location of our C, so to get this angle, we can use 180 degrees minus 67.32 degrees. And the answer there is 112.68. Or if you want, if we use this direction, clockwise direction, then we'll have what? 180 degrees plus 67.32. So if we use the clockwise direction, okay? So following the counterclockwise direction with respect to the positive x-axis, our angle is 180 degrees from here up to there minus 67.32. The result is 112.68. Excuse me. From there, we can say then that the phase angle of the sum of the two sinusoids, their cosine and sine, having the same angular frequency, is negative 112, not positive 112.68, but rather negative 112. How? How do you know that the sign is negative, not positive? Because by formula, sabi nga natin, A cosine omega t plus B sine omega t is C sine omega t minus theta. No? So that's why our theta here is negative, not positive, negative, because of the formula. Because of the formula or the identity of A cosine omega t plus sine omega t equal to capital C sine omega t minus, not plus, not positive theta, but rather negative theta. Okay. So that's why now our answer here for the phase angle, sabi natin, negative 112.68, not positive 112.68. Okay. Then for the period t, again, following the formula, 2 pi over 2, 3.14 seconds, the reciprocal of this correspond to our frequency. So we have how many more minutes? So for the rest of our exercises, so we can simply say for E, ayun, by inspection, the amplitude is 5, the angle is negative, 53, negative. Yeah. T is 3.14 because we have double equal to 2 there, same as here, 3.4. The reciprocal of that is 2.318. So also similar in here, we have the same T and frequency, as well as in H, we have same frequency and F, period and F. Only difference is the magnitude as well as the angle. Magnitude, angle, magnitude, angle. So magnitude is 5, angle is that. And the time period T here, again, is 2 pi over W, say 2 pi over 3 equal to 2.09 seconds, and the reciprocal of that is 0.477 hertz. So yung mga remaining exercise dito, they have the same T and frequency because they have the same W. W2, 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 that's why they have the same T and frequency. Na? Okay, any questions so far? Actually, this is the first lesson. In my interpretation here, first lesson correspond to first week. Lesson 2 correspond to the second week. So I will ask Sir Mark Angelo if it is like that. First lesson correspond to week number 1. Second lesson correspond to week number 2. Pero wala akong nakikitang activity pa dito. So I will ask Sir Mark kung saan ko kukunin yung mga activity. So ibibigay ba sa akin or paano ba? O ako na lang gagawa. Okay, kung binigay niyo sa akin yung mga activity, hintayin na lang ninyo sa messenger ninyo, sa GC natin. 1 week naman ang paggawa ng activity natin, di ba? Deadline naman natin yan will be on next Monday, yung first activity natin. I will ask Sir Mark yung activity number 1 at saka activity number 2 and so forth and so on. Kasi wala akong nakita mga activity sa sinendiyang PowerPoint. Tatanungin ko muna siya kasi kanina lang niya binigay talaga. Wala akong idea kung nasaan ba mga yon. Na? Okay? Question. We have 1 more minute.
Ako po, sir, wala po.
Yung iba kaya. So, ibig sabihin, pag yung iba hindi nagsasalita, okay lang, di ba? Sige.
Wala po, sir. Wala po.
Wala. Salamat naman. Ngayon, may nag-chat. Tingnan ko lang. Wala po. Salamat naman. Bye-bye.